So in this video, we're going to take a look at price changes. Right? So before in the other two videos, we talked about GDP, what it was. Then we talked about the two different ways to calculate it. But now what we're going to take a look at is what happens when we want to compare GDP and prices over time, right? You probably heard maybe some old people when they're not talking about coronavirus. You might have heard them talk about how cheap things were way back when, when gas was cheap or when candy was cheap or you could go down and get ice cream or whatever, right? Now, you probably kind of already intuitively know that, well, that's not a valid comparison, right? If you're comparing prices and income of things 50 years ago to today, you know that the value of money has changed. And so, it's not a valid comparison. So let's talk about how or why that's the case and then how we would go about making adjustments so you can do that comparison, right? So, right, got a question posed here, right? Suppose we wanted to compare the income of people in the 1950s to today, right? Is this a valid comparison? Well, we know the answer is no. It is not a valid comparison. All right. Because we know that the value of money in the 1950s is different than the value today. Right. So we have to find a way to kind of talk about this and then to make some adjustments so that we can compare things over time, because we'd like to be able to do that, right? We'd like to be able to say, are we wealthier today than we were 20, 30, 40 years ago? Or if there's a country that is transitioning from being a poor country to a wealthier country, we'd like to say, are they really becoming wealthier? We'd like to be able to make these comparisons. So let's talk about how we would go ahead and do that. Now, so the idea that that money changes its value over time really brings us back to this idea of inflation. Okay, so inflation is when the value of money falls over time. Now, in a later chapter, we'll really dive into the details of inflation, what causes it, but it really has to do with money, how much money is in circulation. And inflation is when the value of that money falls over time, or another way to say it is that it's a rising price level. That is, things become more expensive because now it takes more dollar bills to get that particular item, okay? All right, so how do we account for this? How do we account for the fact that money in the 1950s had a very different value than today, okay? Well, it turns out there's some nice folks over at the BLS, that is the Bureau of Labor and Statistics, and they spend their days, well, not sure what they're doing right now, but normally they would spend their days collecting data to kind of account for this change in value of money over time, okay? The two most commonly used measures that they come up with are what we call the Consumer Price Index, or we just abbreviate it with CPI, and the GDP deflator, okay? Now what these are indices that are designed to track the change in prices of goods over time, okay? So as the definition here states, the CPI, that is the Consumer Price Index, is an index that captures the impact of price changes on the cost of a typical bundle of goods. All right, so let me explain what that means. The way this works is you take, an average bundle of goods that the typical consumer buys every year, okay? So we're talking about clothing, food, laptops, cell phones, cars, gas, housing of some sort, okay? So they basically come up with this package of stuff that most people typically buy, and then they compute the average price of that packet or bundle of goods every year, right? And so, or technically they do it every month, but really the value we're going to work with is the one that's every year, right? So you would look at the value of that bundle, or the price, the average price of all that stuff in 1980. You'd look at it in 1981, 82, 83, 84, and so forth, right? So if you do that, you can then track how the value of these goods changes over time. Okay, so that's how you put together the Consumer Price Index, right? GDP deflator is put together in a similar way, except it includes a broader bundle of goods. That is, it includes all of the goods and services that are included in GDP, okay? So the way you're going to use these numbers is that if you're ever adjusting the price of something that a consumer would buy, like gas, ice cream, clothes, food, you're going to use the CPI. So we use the CPI to adjust prices and income for consumers. Now, when we would use the GDP deflator is when we are going to adjust the GDP of countries. So if you were adjusting GDP for changes in the value of money, you'd use the GDP deflator. Most other things, you're going to use the CPI, okay? So let's go and start to do a few examples where we kind of use these indices to work through some problems, okay? Now, the first problem we're going to do, which is on this next slide here, is that before we get to adjusting and coming up with different values, we're first going to talk about how we actually would calculate this inflation rate. That is, inflation is a changing value of money over time, but how do we kind of measure that, right? Well, it turns out the inflation rate is simply just a percentage. So if you look at our equation here, it is the standard ye old equation for calculating a percentage, okay? So I take the current price index, I subtract off last year's price index, and I divide by last year's price index, right? Do that, multiply by 100, and you get a percentage. So an inflation rate is just a percentage change in the price index you're looking at, okay? So let's take a look at this, and let's do an example or two, okay? So here is some data from the BLS. This is actual real-world data, right? I slaved away, put in all that time and effort to go browse to the BLS webpage, copy some data over, put it in a table. I mean, it took an exhausting 30 seconds to do, but now for you guys, I'm willing to do that, and you have real world data. All right, so let's go ahead and take a look at inflation, right? So the way this data works is I have the years listed here, and then I have the CPI, that is the Consumer Price Index, in those years. Okay. Now, before we start to do some calculations, I'm going to point out one particular thing. Notice here in year 2000 that the CPI is 100. Okay. So we would call this our base year. Okay. So what we typically do is for our base year, we adjust the CPI so that it's equal to 100. And as you're going to see in a second, this is only done to make the math easier, okay? So on the homework problems, if something asks for what the base year is, you basically find the one where the CPI is 100, and that tells you the one that's your base year, okay? All right, now the base year just means it's your point of comparison, okay? All right, so let's calculate an inflation rate, and let's do, say, from the year 2000 to 2008, okay? So let's do, and I'm going to put it up here at the top. I'm going to switch to red. And let's say, okay, inflation rate is equal to, well, and actually let me label that so it's a little clearer. This is going to be inflation from 2000 to 2008, okay? Well, inflation rate is equal to 100, right? You can take a look on the previous slide, times the price index in the year 2008, which is right here, 125. Right? So it's going to be the price index in the later year, so 125, minus the price index in the earlier year, the first year. Well, that's year 2000. That's this number right here. So that's minus 100 divided by the price index in the earlier year, which is, again, is 100. Okay? So if we do that, we have 125 minus 100. That's 25. So we have 100 times 25 over 100. The 100s cancel, and we get 25%. Okay? So the inflation rate from 2000 to 2008 is 25%. Now, if you look closely at these numbers, you'll see the CPI in 2008 was 125, right? And so automatically, by having a base year of 100, you know that the inflation from 2008 is just going to be 25%. The inflation from 2000 to, say, 2005 is 13.4%, right? So it makes it very easy to do these calculations. So that's why the base year is set at 100. But let's do another example where we won't use the base year. So let's look at the inflation rate from, let's say from 2001 to 2015, okay? Well, let's do this again. Inflation rate is equal to, well, it's 100 times the CPI in the later year, so 2015, so we're going to take this value, 137.6, and we're going to subtract the earlier year. Well, the earlier year is 2001, so we're going to take this value here, and that's 102.8, okay? And then we divide by the CPI of the earlier year, which is just 102.8, okay? All right, so you'll have to punch this into your calculator, right? You're going to type in 137.6 minus 102.8, and then divide that by 102.8, and then multiply it by 100. When you do that, you're going to get 33.9%, okay? So the inflation rate, or that is the change in the value of money from 2001 to 2015, was 33.9%, okay? So that's how you do that. That's how you calculate inflation rates using the CPI, okay? Now, let's move on to the second type of adjustment we can do, okay? But before we start that adjustment, we got to talk about some terms, all right? Now, the terms we're going to talk about are real and nominal, okay? So we have a question here. It says, what do we call prices before we've adjusted them for inflation, right? And so let's first talk about what this means. What does it mean by before adjusting for inflation? This is simply the price in the store. Okay? So you're going to have, well, hopefully you're going to have a little assignment you'll do where you're going to adjust gas prices, right? The nominal, or the price before adjusting for inflation, is that price that someone paid at the pump back in 1950 or 1960 or 1970, right? That's just the actual price. So that's before you've adjusted it for inflation, right? Before we adjust for inflation, we call these prices or values nominal. So this is what we call the nominal price, or the nominal value. Okay? Now, once we have adjusted for inflation, we then call these real prices. So after we adjust for inflation, this is what we call the real price, or the real value. Okay? So before adjusting for inflation, those values are nominal. After we have adjusted, we call those real prices or real values. Okay? So let's go ahead and do some of those adjustments. Now, These calculations are different from when we calculated the inflation rate. Okay. The equation we're going to use to adjust nominal prices and to convert them into real prices is this equation right here. Okay. So the real GDP is equal to the nominal GDP, that is the GDP, say in 1990, times this ratio of the GDP deflators. Okay. So you take the GDP deflator of your base year, and we'll talk about how you select that in a second, okay? And you divide it by the GDP deflator of the year that matches your nominal GDP right here, okay? So we'll do an example and so you can get a feel for how to do this, okay? So that's the equation you will use, right? Now, be aware that in the book, they sometimes call this converting GDP to constant dollars. Okay, so if you see that, that's what they mean. It's just real GDP or constant dollar GDP, okay? So let's do an example or two. All right, again, I went and got some actual data for you guys. Here we go. I've got the years listed here, okay? The next column, I have nominal GDP, right? That's just what GDP was in that particular year, and I've got it listed here in billions. So in 1930, the nominal GDP of the United States was 92.2 billion, right? Going all the way up to 2015, where the nominal GDP was 17.9, so 17,902 billion, which is basically 17.9 trillion, okay? Now, what I have listed here is the GDP deflator. That is, that's our price index we're going to use to adjust these figures. The last column here is real GDP, and that's what we're going to kind of figure out for a couple of these values, okay? All right, so let's do one of these conversions to see. So let's start with 1930, okay? And I'm going to choose 2015 as my base year. Base year, okay? Turns out it does not matter which year you use as your base year, but whichever year you pick, stick with it for all your calculations. If you do that, you are just fine, okay? So, let's calculate the real GDP from 1930 and convert it to 2015 dollars, okay? So, real GDP, and instead of writing out real, a lot of times we just put R and then GDP, okay? The real GDP in 1930, again, if you look at that equation on the previous slide, is equal to the nominal GDP in 1930, which is this value right here. So it's 92.2 times that ratio. Remember, that ratio is the GDP deflator in your base year on top. So our base year is 2015. So we're going to grab 109.7. Okay? The GDP deflator, your base year on top. Bottom is the GDP deflator of the year that matches your nominal GDP. That's 1930. So we're going to grab 9.5 and put it on the bottom. Okay? Okay, you'll pull out your calculator. You'll divide 109.7 by 9.5, and then you'll multiply that quantity by 92.2. Okay? So if you do that, you should get 1,064.7 billion. So we can write that in here. 1,064.7 billion dollars. So what that means is if we take the GDP, the nominal GDP in 1930, and then convert it and express it in the value of money in 2015, it's really $1,064.7 billion. Okay? All right. So let's do this again with the figure in 1990, because I've got a question down here at the bottom that we're going to have to answer. So let's do it for 1990. Okay? So let me switch colors. Let's go back to blue. And let's do it right here. So real GDP in 1990 is equal to, well, nominal GDP in 1990, which is this number here, so 5,900 79.6 times, well, it's going to be the GDP deflator in your base year, which again is 2015. So it's going to be 109.7. Now, again, as I mentioned before, the base year doesn't change when you're doing these different calculations. So notice in both the calculation up here at the top and in the one I just did, 109.7 is on the top of both of these ratios, right? So that's my base year. I keep it there, okay? So the GDP deflator on the bottom is the GDP deflator that matches the year I'm converting, 1990. So it's going to be 66.8. 66.8, okay? So again, take your calculator, divide 109.7 by 66.8, and then multiply that by 5,979.6, and you will casually get 9,819.8 billion. Okay, so that means the GDP in 1990, once it's converted to the value of money in 2015, is equal to 9,819.8 billion. Now, if you want to put that in trillions, that's basically 9.8198 trillion. Okay. All right, so that's how you do these calculations. So now let's turn to the question here at the bottom, which asks, what was the percentage increase of real GDP from 1990 to today? Okay, so this is asking for just a simple percentage calculation. Okay, now I'm not asking for inflation here. I'm just saying what's the percentage change or the percentage increase in real GDP. Okay, it turns out it's the same equation because it's just a percentage, but here I am not asking for the inflation rate. Okay, so be aware of that. All right, well, percentage increase is just equal to, well, real GDP today, which is this number, 17,902, minus real GDP in 1990, which we calculated, which is right here, 9,819.8, all divided by the real GDP in 1990, right? 9,819.8, okay? Now remember, you have to, and I almost forgot it, again, you have to multiply that by 100, okay? So if you take out your calculator, do 17,902 minus 9,819.8, and then divide all of that by 9,819.8, you will come up with 82.3%, okay? So that's how you do these adjustments, and hopefully it is straightforward from there. So now, in the little assignment you're going to do to get some more practice doing this, it's going to be a little bit different. Instead of comparing GDP over time, you're going to compare prices over time, okay? That is, you're going to look at the price of gas for various years, okay? Now remember, if it's something that we as consumers buy, you use the CPI, you don't use the GDP deflator, okay? But the type of equation we're going to use is exactly the same. The real price is equal to the nominal price times the ratio of that price index, okay? So you're going to do the exact same type of calculations you did here, and I'll go back to that slide, except now, instead of nominal GDP, you're going to have the price of gas. Instead of the GDP deflator, you're going to have the CPI. But you're going to do the exact same type of calculations, and this is basically the equation you'll use, okay? So that's what we use to do the take-home assignment, and you should be good to go with that. All right, that is it.